Unlocking extra horsepower from a race car engine often comes down to optimizing the flow of air and fuel into the combustion chambers. One of the most effective ways to achieve this is by porting the cylinder head, a process that improves the shape and smoothness of the intake and exhaust passages. At the heart of this job lies a precision tool, the carbide burr. Understanding how to use a carbide burr cutting tool effectively can make the difference between a head that merely looks good and one that truly delivers more power on the track. Before you begin, preparation is crucial. Start by removing the cylinder head from the engine. Place it on a sturdy workbench, ensuring it's safely secured and protected from accidental damage. Thoroughly clean the head, removing all oil, carbon buildup, and debris. Disassemble the head, taking out all valves, springs, and seals so that you have a clear, unobstructed view of the ports and combustion chambers. This not only prevents damage to these components, but also grants you full access for precise work. Before reaching for the carbide burr, take time to evaluate your cylinder head. Study the intake and exhaust ports, paying close attention to rough castings, sharp edges, or any significant restrictions in the passages. Many performance enthusiasts use layout die to highlight the areas they plan to modify. Compare your head's ports to templates or photographs of professionally ported heads, if available. Mark the regions where material removal is necessary. Typically, this includes smoothing sharp turns, widening bottlenecks, and removing casting flaws. Now, choose the appropriate carbide burr. Carbide burrs come in various shapes and sizes. Round, oval, flame, and cylindrical tips are common. For porting cylinder heads, a flame or oval-shaped burr is ideal for blending and smoothing curves, while a cylindrical burr works well on straight sections or for removing more material. Ensure the burr's shank matches your die grinder or rotary tool, and always use high-quality carbide burrs designed for ferrous metals, as they'll last longer and cut more efficiently. Safety is paramount. Put on safety glasses or a full-face shield, heavy gloves, and hearing protection. The porting process will generate sharp metal shavings and significant noise. Wear a dust mask or respirator to avoid inhaling fine metal particles. With your die grinder fitted with the chosen carbide burr, you're ready to start. Hold the tool firmly and use a comfortable, controlled grip. Begin with a low to medium speed setting. Excessive RPM can lead to chatter, loss of control, or premature burr wear, while too low a speed may cause the tool to grab or stall. Find a balance that gives you smooth, predictable cutting action. When you begin cutting, let the burr do the work. Apply gentle, consistent pressure. Forcing the tool can cause gouges or chatter marks that are difficult to remove. Start in the areas you marked earlier, carefully removing material in small increments. The goal is not to enlarge the ports indiscriminately, but to optimize their shape. Focus on smoothing transitions, removing casting bumps, and easing sharp turns that impede flow. Work methodically, frequently pausing to inspect your progress and clear away chips with compressed air. Pay special attention at the short side radius, the curved section at the bottom of the port, which is critical for flow. Blend this area smoothly, easing the turn without making it so thin that it becomes structurally weak. The roof and walls of the port should be gently blended to remove steps or ridges that can disrupt airflow. Avoid removing material from the port floor except to smooth casting lines, as this can lower the port and negatively affect flow dynamics. When shaping the intake port, aim for a slightly textured finish. Unlike a mirror polish, which can cause fuel to drop out of suspension, a fine uniform texture helps maintain the fuel-air mixture as it travels into the chamber. On the exhaust side, a smoother finish is advantageous as it reduces carbon buildup and assists in the exit of spent gases. Throughout the process, maintain symmetry. Uneven ports can cause differences in cylinder filling, leading to inconsistent power delivery and, in extreme cases, engine damage. Use calipers or inside micrometers to check the dimensions of each port. Strive for consistent shapes and sizes from port to port. Occasionally, you may need to switch to a different shape of burr for tight corners or specific contours. Always stop the tool and wait for the burr to come to a complete halt before changing it. Remember to periodically lubricate the burr with a light application of cutting fluid, if recommended by the manufacturer, to reduce heat and prolong tool life. As you approach the valve seat area, exercise extreme caution. The seat is a precision machined surface essential for sealing the valve. Removing too much material here or nicking the seat can require costly repairs. Blend up to, but not into, the seat area. If you need to deshroud the valves, removing material from the combustion chamber to allow better airflow around the valve heads, make only subtle, controlled cuts and check your work regularly. Once all ports are shaped and blended, follow up with abrasive rolls or cartridge rolls to smooth the surfaces further. These are mounted on the same rotary tool and can refine the finish left by the carbide burr. Work through progressively finer grits, aiming for a finish tailored to the intended use, slightly rougher for intake, smoother for exhaust. After porting, meticulously clean the cylinder head to remove all metal shavings and abrasive dust. Use solvent, compressed air, and thorough rinsing, paying special attention to all oil and coolant passages. Any debris left behind can cause catastrophic engine damage. Finally, reassemble the cylinder head, ensuring all clearances and tolerances meet specifications. When the head is reinstalled on the engine, properly torqued and matched with performance gaskets, the benefits of your work will be realized. Improved airflow translates directly to better cylinder filling, more efficient combustion, and ultimately, more horsepower. The careful use of a carbide burr in cylinder head porting is as much an art as it is a science. Patience, attention to detail, and a steady hand can unlock hidden potential in your race car's engine, delivering the edge you need on the track.